Okay, let's take a moment here to look at linear equations in standard form. So standard form is when you have your x and your y on the same side of the equation. Whatever. That's enough. X and y on the same side of the equation. So there's a little trick we use with standard form equations when we're solving systems of equations using elimination. And the little trick relies on this fact that, which you all know from Algebra 1, that if I do something to one side of the equation, I have to do the same thing to the other side of the equation as well. So I can double this side of the equation to make it 14, but then if I do that, I have to double this side to make this 10y and 4x. Or I could think of it like I could double it again if I wanted to. I could write it this way: 2 times 4x plus 10y equals 2 times 14, and I'd use my distributive property to get 8x plus 20y equals 28. Right. And we check that this process of doubling each side, where I could multiply by any number I wanted to, or even divide, doesn't change the solution to the equation. So, for example, one solution to this equation is the ordered pair 1, 1. X equals 1, y equals 1. So 2 times 1 is 2. 5 times 1 is 5. 2 plus 5 is 7. But the same is true down here. 8 times 1 is 8. 20 times 1 is 20. And 20 plus 8 is 28. Or 4 times 1 is 4. 10 times 1 is 10. 4 plus 10 is 14. So the same pair, xy pair, makes each of these equations true. They all have the same set of solutions. If you recall, the set of all solutions for any linear equation like this is a straight line. It's all the points that form a straight line. And so this equation, and this equation all have the same solution set. They're all the set of points that make the same line. So if I were to graph these three equations, I would have the same line every time. Here's another one over here. A particular solution to this is the point 2, 1. 2 times 3 is 6. 7 times 1 is 7. 6 and 7 is 13. I could say double everything. So I have 6x plus 14y equals 26. And then I have 2 times 6 is 12. 14 times 1 is 14. 12 and 14 is 26. So 2, 1 still works. I could multiply the original equation by 3. So I have 9x plus 21y equals 39. Then I'd have, let's see, 9x. 9 times 2 is 18, plus 21 times 1 is 21, and that gives us 39. So it still works. I could make everything negative. I could multiply everything by -1. I'd have negative 9x minus 21y equals negative 39. It still works. So as long as I multiply both sides by the same amount, then I still have an equation that has the same solution set, same ordered pairs will make it true, and if I graph it, I get the same line. So if I want to say, for example, figure out, I don't know, is there an equation that fits this pattern that has this same set of solutions, that's ax plus by equals, say, 65. I say, well, okay, so from 13 to 65, let's see, 65 is 13 times 5. So I've multiplied 13 times 5, and so that must be the other side, 3x plus 7y times 5 as well. So I must have multiplied both sides by 5. So that means that 15x plus 35y equals 65. We can just check here with our, our one ordered pair we know works. Let's see, 15 times 2 plus 35 times 1 is 65. So that's 30 plus 35 is 65, and check, that works. So I found an equation that fits this pattern, that has the same solution set as the others, but has a 65 over here as the constant term. And that is a kind of, you can think of it as like scaling up and down linear equations in standard form.